Okay. So hi, my name is Ray Loy. I'm the ATPESC program director, a member of the performance engineering group at Argonne at ALCF, Argonne Leadership Computing Facility, and also the lead for ALCF training. And also with me today is Yaseman Gadar, who's my deputy for ATPESC. Yasi can wave. I think you can see her. I
Yes.
see her video. So, so we're the two most involved people with running ATPESC, but there are a cast of thousands. So I'm just going to spend 10, maybe 15 minutes giving a little overview of ATPESC, and then get to what I think you really want to know is kind of advice about applying. So, right, so the motivation of ATPESC is that conducting research in computational science is hard, and it's ever increasingly complex due to new by necessity. The computer architectures used are cutting edge, and the software as well as the hardware are complex and not so easy to leverage. So ATPESC's mission is to help train the next generation of computational scientists. Little history of ATPESC. It was founded by Paul Messina in 2013, and it's organized sort of like a retreat. We have really as many speakers, computational scientists and HPC experts as we do attendees. So over the course of the 2 weeks, there are roughly 70 speakers involved. So it's a large operation to organize. So the target audience is advanced doctoral students, postdocs, and early career computational scientists. We have seen a trend that people are coming to us prepared earlier in their doctoral studies, and that's okay. So we cover all the costs to participate, almost everything. We pay for domestic airfare, meals and lodging. There may be a few things like travel from your house to your local airport is not something we cover, and things like that. But for the most part, we cover all of the expenses. So when you submit an application, there's a large review committee that reviews them. This is just like a competitive, if you submitted a paper to a conference or something, we evaluate the applications on a variety of criteria, and I'll talk more about that later. So pretty much any information you would want about the program is on our website. So I strongly recommend you go and visit it and poke around. extremecomputingtraining.anl.gov. And just a few words about Argonne National Lab. There are many DOE national labs. The three that are most relevant to scientific computing are the two supercomputing sites, I guess, if you want to use the term, the Argonne National Lab and Oak Ridge National Lab. So the Argonne Leadership Computing Facility and the Oak Ridge Leadership Computing Facility. So the leadership computing implies doing things at large scale, right? So those are the two sites for that. And then the third site is NERSC, run by Berkeley Lab, and NERSC's emphasis is more on capacity computing, so lots of supporting lots of small runs. right? Whereas they refer to our niche, Oak Ridge and Argonne, to be capability computing. So if you are not all that familiar with Argonne, the Argonne Leadership Computing Facility is just one of the so-called user facilities at Argonne. User facilities means it's something that Argonne provides for researchers that are not necessarily at Argonne. So the Advanced Photon Source is a large synchrotron that researchers can come apply for time on. And same thing with the ATLAS accelerator, the tandem linear accelerator system. The Center for Nanoscale Materials is actually, that building is on the periphery of the APS over here, I think, or over there. And there's also an electron microscopy center. So this is sort of hot off the press. We have a picture of the Aurora machine, which is currently being in the middle of installation. We have a test and development system already up, and early users are using it, and we're receiving parts to fill out all of Aurora on a daily basis. So the users of the Argonne Leadership Computing Facility are scientists from all over the world. So that's our user base. It's not just Argonne researchers. So where is ATPESC held? There's a conference center in St. Charles, and if you're not from this area, you are probably not familiar with it, but here's a little map. Downtown Chicago is over here. Argonne National Lab is at this pin. We're about 20 miles southwest of Chicago downtown. It's considered the southwest suburbs. And this pin is Fermilab, just so if you are wondering where Fermilab is in relation, and the Q Center is somewhat near Fermilab. It's a very nice place. We've had multiple ATPESCs at this location. And this was our class last year. We were very happy to return to an in-person event after 2 years of having to do it virtual due to the pandemic. And it also happened to be last year, the anniversary 10th event for ATPESC. And excuse me, the founder, Paul Messina, is cutting the cake there on the right side. So the ATPESC curriculum is broken up into 8 tracks: hardware architectures, programming models, data-intensive computing and I/O, visualization, numerical software, performance tools and debuggers, software sustainability, and machine learning. So we do make adjustments to the curriculum every year to stay relevant. Over the last few years, we've progressively increased the GPU-related content. We haven't settled on a final agenda for this year yet, but there will be changes. People who attend ATPESC will have access to the machines at ALCF. I don't think that Aurora is certainly not going to be completed by then, even though it's in progress now. And the test system is, I believe, not, we're not able to let anyone on other than a very select group due to the status, NDA status, and so forth. But people will have access to our production machines. Polaris is a very new machine with GPUs in it. And at OLCF, previously we've used their Ascent system. We might get arrange access to more this year, depending on what the tracks are looking for. And also we have access to the NERSC machines. So the general goal is to try to broaden your experience, right? The typical candidate attendee of ATPESC has had some experience in a few areas of high performance computing, but you probably don't have a broad appreciation for all of these topics. So we're here to round out your at least familiarize you with the whole range of possibilities that you might want to pursue in greater depth later. And a big part of ATPESC is the face-to-face aspect that you can actually work with the speakers one-on-one while you're at ATPESC doing hands-on activities. So there is a page, so that concludes the overview of ATPESC. And I think we'll move on. If there are any questions, please speak up or add them to the chat. But I will then move on to tips and the strategy for applications. Okay, so this is a snapshot of the application instructions. I strongly recommend reading it all. It's not that long, and taking it to heart. In particular, what I wanted to say was that the criteria to the prerequisites to attend things like the type of experience that you have, that is, for example, whether you have experience with MPI, OpenMP, or data science frameworks, that's what we're looking to establish details about that to substantiate it when we are looking at your application. So it's not good enough to just have the experience. We need to have you talk about it and have your letter of recommendation support those details. Right? And or letter of recommendation, your CV and your own statement, right? We need details. I kind of touched on this before, but people see the statement about on the webpage about doctoral students, postdocs, and computational scientists interested can apply. People then send us questions saying, well, I'm a faculty member and can I still apply? Well, you must be doing computational science, otherwise you wouldn't be interested in the agenda. So you're already covered by the statement, but some people seem to be thrown by that. So I just want to say outright that if you have the experience that's required to apply, and you would get a benefit out of it that you could then use, then you're somebody who should apply. And if it doesn't exactly fit the mold, like, if you got your PhD when you were age 10 and you are in a graduate program or something, then, explain the situation when you apply and, why you think that you are a good fit for the program, and we'll certainly take it into consideration. There's no strict, it's not the case that you must be a postdoc to attend or something like that. There are no strict rules about that. This is just the typical situation. Right, so right, the three big categories that applications are rated on are the prerequisite experience, right? The first bullet, MPI, OpenMP, or data science. Then, right, so you'll get a, the review committee will give a score for that, whether you meet that criteria. And same thing for, have you used some kind of an HPC system? And I'll say more about that on the next slide, I think. And then what are your plans after we teach you all this stuff? What are you going to do with it? Hopefully you're going to go forth and do research and publish papers or something, right? So the three things that are submitted to support the three things at the top, right, are your statement of purpose, your letter of recommendation, and your CV, right? So we are looking at those three to get the picture of how well you meet the eligibility criteria. Right, and I can't emphasize enough, details are what make a successful application. All the time, when either I or other members of the committee are reviewing applications, we're just not sure. Someone says that we're not sure whether someone has inherited someone else's code that they don't really understand, or whether they've actually worked on it themselves, or whether they have really run anything. It doesn't. When there's doubt, then scores tend to be low. Let me put it that way. So let me give you some examples. If somebody, let's just say we're talking about MPI, right, which is only one of the three possibilities here. If someone says, well, I took a class in MPI, and they never say anything else about it, I mean, well, that doesn't really mean much about, do you have a working knowledge of it, right? The working knowledge doesn't have to be 20 years experience, but if MPI is what you're saying that you're gonna meet that part of it, then we need a little stronger statement, like you actually wrote something, you developed the code, you tested it, or you took an existing code, and these are the parts of it that you expanded, and it worked this way, and I improved the time, or it scaled better than when I started, or something like that, right? The more, when we have info like that, then we can say, okay, this person knows something about MPI, and that category can get a good score. And we know that people work in groups, research groups work as teams, and so forth, and that's fine. But we need to have some clarity about what your individual contribution was. So don't gloss over that. Otherwise, there's doubt, and doubt means lower scores. So going back to the experience on HPC systems, we know that you haven't necessarily run on a system like we have at Argonne. I mean, you might have some kind of a university cluster or something like that. Or if you're a corporate person, you may have some, computing facility there. As long as it's something bigger than running on your laptop, that is a good sign, and it's relevant, right? So whatever you have run, tell us about it. excuse me. And you know, this is also speaks to detail that if you know, are you changing the code, improving it, and then running it, or you just taking somebody's turnkey code and running it? If we're not clear, then we don't know what to do. And when it's clear that you understand how to use, let's say, a batch submission system that you've actually run at some kind of decent scale relative to the system that you have available to you, right? Like I said, we don't expect that you necessarily have had access to a supercomputer, but whatever you had, did you take advantage of it? Just saying that, well, I ran this code, this MPI code. Well, how many nodes did you run it on, or how many cores? And did you do any benchmarking on it? That would be of interest. Shows that you understand, even if you just timed it under different circumstances. That doesn't have to be super involved, right? We do cover a whole day's worth of performance tools. So, but if you did some basic stuff, then that speaks to your experience with the system, right? Did you have to write job scripts, and was it just a couple of runs, or were you doing a science campaign where you had to run a bunch of stuff and do post-processing or something like that, right? So all of these help us understand the situation. And then the third leg of the stool here is what your plans are. So this is going to vary probably, the most widely, the other two categories are fairly cut and dry. And this is much more, everybody has a different situation, has different plans. It might be easy to explain, or it might be a little harder. You might be, if you're, let's say, finishing up, your doctoral work, for example, you may be applying to postdocs. That's relevant. We know that you may be in a transition, so let's just explain what your situation is and what your plans are. You've headed for industry, or are you continuing in the position where you are? That kind of thing. So I strongly recommend everybody subscribe to the mailing list. It's actually, the link is not just at the bottom of the page. There's another link at the top as well now. I forgot I added that. So if we have any instructions, additional instructions, or anything like that, we would send it to that mailing list. And then if you have any questions after this session, you can feel free to email us at support@Extreme Computing Training. So kind of wrapping up here, ATPESC is currently funded by ECP. If you're connected to ECP at all, you know that the whole ECP project is winding down at the end of the calendar year. ATPESC will continue. There will be funding scraped up from somewhere else, but we haven't figured that out. But Argonne is committed to continuing the ATPESC program. So this will be the 11th one, but it is certainly not the last one. Okay. I think, oh, there's a question in the chat. Okay, I will